Becker comes along and says, okay, why do mammal regeneration suck? Because you mentioned earlier, we have great regeneration in bone and great regeneration in our liver. You should do a hard stop and realize, where do those nucleated fetal red blood cells really come from in mama? Where's that umbilical cord connect to? Oh, the liver, doesn't it? Right? Through the falciparum ligament and all those ligaments you learned in anatomy. And you go like, yeah, what the hell is the purpose of this? Why does everybody have a belly button? It turns out that ties to this story too. So Becker realizes that the DC electric current has to be augmented some way. The augmentation is what you started the podcast with me earlier. You said, Jack, I want to have a discussion about the leptin melanocortin pathway. Well, guess how you get the rest of the regeneration program? Turns out the sun's light is the part that's missing that we don't have, that salamanders have, that frogs have, that everybody else has. Why? Because it turns out when melanin is hydrated by that deuterium depleted water, it takes a current and down regulates it to 1/1,000,000th of 1 ampere. Guess what the size of the current was in Becker's work that dedifferentiated a red blood cell in us? 1/1,000,000th of 1 ampere. So guess what? It turns out that the leptin melanocortin pathway is actually the regeneration loop. This is the evolution of CCO in hemoglobin that you just saw recapitulate in the leptin melanocortin pathway. And what does that mean for mammals? Mammals scar, they don't regenerate. The only places they're able to regenerate is where the organ tends to be hypoxic and they have a lot of nucleated cells around, which bone and the liver fit the bill. What's the cell that doesn't? The one that you're a neurobiologist and I'm a neurosurgeon. That's the reason why when you put brains constantly in blue light non-native EMF, what do we get? We get atrophy. What does atrophy come from? You know that answer. You're a biologist. That's apoptosis. When you have unfeathered apoptosis, that's neurodegeneration. That's not a good thing when it's in your brain. It's a good thing when you're in the fetus and you want your fingers to separate, because that's what apoptosis does. But it's not good when you're Nick and Jack talking via Zoom. We don't want that. We don't want people to get Alzheimer's, frontal temporal dysplasia, Parkinson's disease, but that's effectively how the regeneration pathway goes bad in us. Why? All because of a paramagnetic switch called nitric oxide that keeps your stem cells in an atavistic state so the biophotons that are created from mitochondrial DNA can sculpt your life. That's the story of the GOE, my friend. Brought to you now, 2.4 billion years to 2025.
Let's talk about the origin, or the radiation, I should say, of mammals, because this is another, so the cartoon story here that I'll just assume people have some familiarity with. Dinosaurs rule the world. Asteroid hits Mexico, blocks out the sun, kills most of the dinosaurs except the ones that turn into birds. But then mammals, which are essentially just little rodents living in tunnels, they radiate very, very quickly after that catastrophic event. And again, when we go through the story,
both have in common. Just tell the audience, eutherian mammals and theropod dinosaurs are the two people that made it through the fifth extinction.
Yes.
The question that you need to pose to you and the audience, what do they have in common?
Fur and feathers.
They both have huge mitochondrial capacity in different parts of their body. Turns out theropod dinosaurs have it in their wings so they can fly. That means they can go to where the sun still is to eat. And why do mammals survive? Because when the T-Rexes are walking around, they are underground, not living in the sun, because they're hypoxic and they're able to make huge amounts of light from inside themselves. And they use this really cool gene in them called POMC to actually create glucose from light through a process called ACTH and cortisol. They can make glucose from light.
How much?
A lot.
So you're saying an animal like this could survive in the absence of food would be essentially what that means.
And remember, they're small little animals, right, that lived under the ground. What do you know about in the ground? Why do French people keep their wine in the earth? Because magnetic flux is higher. What does magnetic flux mean for the ATPase? Spins faster. So that means You just offset your need for food, and then you're able to, through the cortisol cycle, actually make blood glucose there. Most people don't know that light, we always talk about light that you and I are in, which is blue light now from LEDs. You don't realize that the blue light that was made in their mitochondrial DNA stimulated them to make blood glucose. This is the reason to this day, you go look at Nora Volkow studies where she puts cell phones up to the side of people's heads. It raises your blood sugar, your insulin levels, and your triglycerides without you eating anything at all.
Yeah.
So
Light
you
is
as a
sufficient to do that.
biochemist, right? You as a biochemist now have a duty to me to say, wait a minute, you're telling me, Jack, this is published and I don't know about it. That's the hard stop. That's the reason why I'm telling you the story I just told you in the GOE is the biggest story never told in biochemistry. And that famous guy that I know you know about in Boston named Michael Levin, who's working on bioelectricity, and he knows that polarization and depolarization are important. What he doesn't know, that it's photobioelectricity that's the key. The light is what determines that oxidation state. It determines how the electricity is distributed in the body through the cells, through the electrical resistance pathways that are there. And guess what? I'm going to tell you right now, Nick Lane is a little bit ahead of Michael Levin in Boston. Why? Because he's beginning to realize that this story that I'm laying out for you, it's much more biophysical than it is biochemistry. Why? Because it turns out Nick Lane has already figured out that all metabolic fuels basically run their own game. They don't need to be told what to do. They're just cycles on top of cycles. The interesting part is light is Archimedes' lever that tells these things how to go and when to go. And it turns out oxygen is the big one because when oxygen is present, you're going to default to TCA. That's the reason why our most special organ, the one that I'm an expert on, the brain, uses 20% of our cardiac output. So it means it's an obligate aerobe. Doesn't mean that it go back to the GOE event. It can, but it suffers. It uses lactate. When you were probably in school, they told you, oh no, the brain needs to use glucose. We now know that's bullshit. We know that lactate is used. Why? Because it creates huge electrical resistance in the brain that actually allows the brain to function well for a long period of time while we can't use the TCA cycle. So even modern science is catching up to Uncle Jack a little bit. But what they don't know, Nick, and I want to make sure you understand my perspective fully before you critique it. I want you to understand that you as an evolutionary biologist need to look at the GOE and what's happening today as a fractal. The same thing that happened then is still recapitulated in us, but the way in which we're controlling the levers is all through light and biophotons. That's ultimately what makes the choice. And the thing that the whole process is quantized to actually is what happened at the GOE. It's oxygen. Oxygen being paramagnetic determines many, many things for cell fates in us. And it turns out the time that we're the most regenerative is when we're inside an amniotic fluid bag. Mm-hmm. That should stun you and go, wow. And then you should start thinking, okay, now this starts to make sense why people who are diabetic have no superoxide pulse and have shitty nitric oxide because they never go outside. They're never in the sun. Mm-hmm. That's why they don't heal. They never get to Becker's regeneration currents. Duh, because they're watching Jerry Springer and they're inside behind glass, which blocks what? UV and near-infrared light. Here's the story about near-infrared light from the sun. Near-infrared light penetrates all the way through your body.
Yeah.
What it does. If you look at the 1992 Nobel Prize, do you know that when you introduce near-infrared light to hemoglobin, it disassociates from hemoglobin, allows it to carry more oxygen. Isn't that the fundamental problem in diabetics? Yep. They're hypoxic. And the problem is when your mitochondria is hypoxic, but you have oxygen around you, that means you have created a huge mismatch. That mismatch fosters heteroplasmy at the mitochondrial level, which you can't get rid of because apoptosis is broken. That's the reason why diabetics get fat. It's the reason why they get cancer. It's the reason why they get PAD. It's the reason why they get fucking every disease you can imagine. Why? Because of the biophysics problem, not the biochemical problem.
So let's just make this concrete for people. Let's say someone is diabetic, type 2 diabetic. What do they do in terms of their relationship to different wavelengths of light and the timing of their exposure to help get better?
Yeah, that's the easiest thing because I've said it in every podcast. The problem is when I say it to you, I think now that you understand the perspective, you'll understand this better. You make like the Sphinx and eat like a great white shark. Why? Because when you make like the Sphinx, you're grounded so that you're getting free electrons off the earth as the sun hits there. So that replaces the food. You're looking to the east because what happens when you look to the east? That's how you repair CCO every morning as a reset default. You're creating deuterium depleted water, keep that electric current inside you, and you're fixing apoptosis so that the bad engines that need to be taken out can be taken out and you can undergo mitophagy.